Okay, so we've got to decide here which transformation formula here is represented here in figure 2, okay? When you compare it to figure 1, what does figure 1 become here in terms of the transformation? What I like to do is to eliminate, okay? I like to get rid of the ones that don't apply. So when I compare here what I have to start with to the transformation, what I notice is the y values, okay, haven't changed. Right, so the graph looks completely different, but if you look, the y values stayed the same. You've got two y values here that are 0, and a third y value that's 6. It's exactly the same here. Two y values that are 0, a third which is 6. So it cannot be the first one there, because that would shift the graph up or down. Y values would change, and it cannot be this one here, because that would stretch in the y direction, because you've got the r outside timesing f of x. It would stretch the y values. So it's got to be the one in the middle. In other words, it affects the x values. And indeed, the x values have changed, if you notice. And if you look at it, there's an 8 there, minus 4, and there's a 2. Well, all of a sudden then, you've got 2 here. That's different. Minus 1 here. Well, that's different. And then you've got minus 4, which kind of might throw you off a little bit. However, the x values on the whole, okay, have changed. I'm going to show you in a minute that all of them have actually changed. All right. But let's ask ourselves, what have we actually done here to the x values? Let's just focus on the maximum. That's what I would do. What's happened to 2 here to get to minus 1? Well, if you think about it, to go from 2 to 1 to start with, let's ignore the minus. To go from 2 to 1, you've got to halve it, haven't you? Okay. From 2 to 1, you have to halve 2 to get to 1. To go from 2 to minus 1, you've got to halve it and, well, divide by 2, or divide by minus 2, or times it by minus a half, okay? So if I effectively, x value there is 2, if I times that by minus a half, I'll get minus 1, all right? Now let's see if that rule works with other ones. Well, let's look at this here, the 8 here. If I times that by minus a half, okay, well, half of 8 is 4, okay, but of course there's a minus then, makes it minus 4. Alright, so that's where that point has gone to there, isn't it? This point here, if I times this by minus a half, well, times it by a half, you get minus 2, but if I times it by minus half, it becomes positive 2, so it goes there. So it works, doesn't it? The x values have been times by minus a half, alright? But in terms of what q is going to be then, remember, in the bracket, you've always got to put the opposite of what you're actually doing. So in terms of what q is then, because you times in by minus a half, q then, well, the opposite of that will be minus 2. Yeah? So in the bracket then, you're going to put f of minus 2x. Okay? And always think then, look at this, what's the opposite of that? Well, here we've got minus 2 times x. The opposite of that will be dividing by minus 2, which is, of course, what we've got there, what we saw earlier.